Hello, IB seniors. I want to briefly show you an example of how to solve trig equations by hand. And so all you're going to see is my hand. All right, so first you're going to do is a couple algebra steps. You're going to bring the 1 over there and divide by 2. That's pretty basic two-step algebra. So we get cosine x equals 1/2. We'll look at this later on. Let's solve this for now. All right, x equals 1/2. So what you're going to do, where does cosine x equals 1/2? Well, you can get that from a calculator, but we're doing it without a calculator now. You can do an inverse cosine. From the unit circle, can we see that? Cosine is equal to 1/2 right here at pi thirds. So that's our principal answer, pi thirds. So we know that x, one place, is pi thirds. But you know there's a lot of repetition on the unit circle. So there's another place as well. One place at pi thirds, another place is down here at 5 pi thirds. You can call it 5 pi thirds, or you can call it a negative pi thirds. Either way, let's call it 5 pi thirds. All right, and there are many more answers as you loop around the circle over and over and over again. So dot, dot, dot. That's your kind of a general solution there. Now we go back and look at this interval here. This says they only want answers that go between 0 and 2 pi. Well, these are the only two answers that exist between 0 and 2 pi, because 0 to 2 pi means going around the circle one time. So at pi thirds, we had a cosine of 1/2. At 5 pi thirds, we had a cosine of 1/2. So it turns out those are the only two solutions that we want. That is our solution set for this problem. Now, if it had said from 0 to 1 pi, we would exclude this one here, because as we go from 0 to 1 pi, there's only one solution here. So you're going to need a copy of this handy. There's a copy of this in the student resources file. There's also one, I think, included in today's folder. But after a while, I'm going to show you a quick way of memorizing this. Some of you already know this from Mr. Smith, how to memorize the values of these critical angles here. But for now, we're just using this to solve equations here. All right, let's do a sine equation real quick then. Let's say we have this. Let's say we have sine x minus square root of 3, and there's a 2 over here. Let's make that a plus, make it a little bit more complicated. And let's say that's equal to 0. Again, we're going to do a couple of algebra steps. We're going to subtract square root of 3, divide by 2. Oh, let's say the domain this time is, let's say they only want you to go from 0 to pi, let's say. Sometimes they'll include the last number, sometimes they won't. Let's say they include it this time, but not that it's going to make a difference on our answer. All right, so sine x equals this here. So where does sine equal negative square root of 3 over 2? Sine doesn't equal negative square root of 3 over 2 anywhere up here as we go to 0 to pi. So basically the answer here is no solution. No solution over this interval. And that'll happen sometimes. All right. If it said 0 to 2 pi, then we would have included 0 to 2 pi sine. Remember the second number. We would have included this value at 4 pi thirds and 5 pi thirds. So this interval is very critical. All right, let's do one more here. Let's do a tangent one. Let's say we have 4 tan x minus 4 equals 0. Well, you're going to add 4 and divide by 4, you get tan equals 1. Now, at the end of last year, when we were doing this homebound schooling, you should have learned a little bit about the unit circle, and that the tangent is the second number, the sine over the cosine. So, for instance, the tangent here would be the 1/2 divided by the square root of 3 over 2. If y'all can see that on there. The bottoms cancel out, and so basically the tangent at this position is 1 over square root of 3. That would be for the tan. Remember, the first number is a cosine, the second one's a sine. But if you notice here, we're trying to get a value of 1, right? So where does tangent equal 1? Tangent equals 1 here. When I take this divided by this, I'm going to get a tan value of 1. When I'm at pi fourths. So let's say here the interval was also from 0 to pi. Let's say 0 to 2 pi. Let's go all the way around. All right, if it's 0 to 2 pi, well, here's one place where it equals 1. That would be at pi fourths. Another time when it's going to equal out to 1 would be down here at 5 pi fourths, because at 5 pi fourths the two numbers are identical, and when we divide one by the other, the sine of the cosine, we're going to get a value of 1 there also. So 5 pi fourths would be the other solution. Pi fourths, 5 pi fourths. All right, now this is a very brief introduction to the idea. There's a lengthier, more thorough video posted in today's folder as well. But see what you can do on these problems, and if you want, you can always check yourself on a calculator, but the calculator is going to give you these answers in terms of a decimal number. That's all for now. Talk to you later. Bye.